In this video, I will be explaining how I constructed my electric motor, the physics behind its function, and how this experiment demonstrates the motor principle. To create the electric motor, you will need the following materials: a 6-volt cell. The voltage can vary depending on how powerful you want your motor to be. However, you don't want the voltage to be too high, otherwise the paper clips will melt. You also need alligator clamps, duct tape to tape down the cell and the magnets, a thin copper wire, a slightly thicker insulated wire, a magnet or magnets. In this case, I use 2 magnets because in my analysis I will be comparing the magnetic field and its influence on the frequency of the current loop when comparing 1 magnet versus 2 magnets. Scissors, a small cylinder, in this case I used a highlighter, and 2 paper clips, which are used for the current loop mount. And now I will perform a demonstration. So you connect the alligator clamp to the paper clip. And now for the other alligator clamp. It will begin to shake. And now it will spin. And it's spinning in this direction, and I will explain why. The current loop spins because it is within a magnetic field, and there is a current running through the wire. The current is provided from the battery. The magnetic field allows for the charges traveling through the current loop to feel a force. Since the positive terminal of the battery is on this side of the battery, it causes the current to flow in this direction. And the magnet is beneath the current loop, meaning that the magnetic field will be going from north to south. So we have the current flowing in this direction, and the magnetic field is going from north to south like this, meaning that the force will come out of my palm this way. And that is what causes, let me just move that over here, and that is what causes the current loop to rotate in that way. The charges moving to the right at the top of the loop will push back into the wire, whereas the charges at the bottom of the loop will feel a push out of the string towards this paper clip. These forces moving in opposite directions work together to turn the coil. One of the challenges that one may face when conducting this experiment is that the current loop may swing back and forth like this, 180 degrees back and forth, but not completely rotate. To fix this problem, it is possible to create a commutator in the current loop. You can do this by scraping off the bottom of the insulation of the wire so that when the current loop is at 180 degrees, the current is temporarily shut off, and that's where the commutator kicks in. The current loop then can continue to coast through the rotation as the current has been temporarily shut off. As we saw in the demonstration earlier in the video, it is clear that the motor principle is being demonstrated. Thank you.